Good morning, guys. How are you? Hope you're doing great. Today we're going to start a new lesson, which is tangent and circumscribed angles. Will be lesson 19.3 and prepared by me, Ms. Salma Ahmed. Let's see the contents that we are going to talk about. Tangent-Radius Theorem, converse of the Tangent-Radius Theorem, and circumscribed angle theorem. Let's know the tangent-radius theorem. If a line is tangent to a circle, then it is perpendicular to a radius drawn to the point of tangency. So here we have the circle, and we have a straight line which is tangent to that circle at that point, and this is the radius. So the relation between these two line segments, or that line and the radius, it is a 90 degrees or perpendicular to each other, as the theorem mentioned. Both lines in the figure are tangent to the circle, and AB line segment is a diameter. What can you conclude about the tangent lines? I need to find the relation between these two tangent lines. So as I have, this is a tangent and this is radius, so it will be 90 degrees here, and this is a radius and this is tangent, so this will be a 90 degrees also. So I think that these lines are parallel lines. So since the tangent lines are both perpendicular to AB line segment, they are parallel to each other. Let's see the converse of the tangent-radius theorem. I think that this is the inverse of the previous one. If a line is perpendicular to a radius of a circle at a point on the circle, then it is tangent to the circle at that point on the circle. Circumscribed angle is an angle formed by two rays from a common endpoint that are tangent to a circle. So here we have our circle, and I have two tangents or two rays from outside, and they are common at endpoint outside of the circle. The angle included between these two rays, it's called a circumscribed angle. So here, this is the circumscribed angle. What is a circumscribed angle theorem? A circumscribed angle of a circle and its associated central angle are supplementary. So here I have these two rays. They are tangent to circle C at A and B. So the theorem is saying that the angle of AXB and angle ACB are supplementary. So both of these two angles, which are opposite to each others, are equals 180. So measure of angle AXB plus measure of angle ACB equal 180. This is the circumscribed angle theorem. Exercises. Use the figure for exercise 1 and 2. You use geometry software to construct a tangent to circle O at point X on the circle, as shown in the diagram. Let's answer the first question. What do you expect to be the measure of angle OXY, and explain? What do you expect OXY? What's this angle? He's asking about that angle. According to the theorem that we took it from a while, I think that this is a radius and this is a tangent at point X. So the relation is they are perpendicular to each other, or the measure of angle, it will be 90 degrees. So it will be 90 by the tangent radius theorem. XO line segment and XY line segment are perpendicular. So measure of angle OXY equals 90. Another question, suppose you drag point X so that is in a different position on the circle. Does the measure of angle OXY change? And explain. So if I drag this X or I move it to other position on the circle, I think that the angle, it will stay as it is, because if I connect the center with any position on X on the circle, it will be a radius, and the tangent will be at that point, so the relation stays as it is, which is 90 degrees. So no, the measure will not change. The tangent-radius theorem still holds, and measure of angle OXY stays the same. Another example. In the figure, RQ line segment is tangent to circle P at point Q. What is measure of PRQ? Explain your reasoning. So here I have this circle, and I have tangent, which is RQ, and I have this is a radius PQ. So I think that this will be a 90 degrees, and I have measure of angle P, which is 59 degrees. I need to find measure of angle R, this one. So as this is a tangent, so and this is a radius, so it will be a perpendicular to each others. So it will be perpendicular to the radius. RQ will be perpendicular to the radius, so the measure of angle PQR equals 90. Okay, from the theorem of triangle sum, that any three angles inside our triangle, it's equal 180. So if I add these three angles inside the triangle, it equals 180. So measure of angle P plus measure of angle Q plus measure of angle R equals 180. Let's substitute the known angles that we know. So measure of angle PRQ that I need to find plus 59, here is 59, plus the 90 from the relation or the theorem that we took from a while equals 180. By adding 59 and 90 by calculator, it will be 149. I'm going to move it to the other side by a different sign. So it will be measure of angle PRQ equals 180 minus 149 degrees. By using your calculator, it will be 31 degrees. So measure of angle R or PRQ, it is 31 degrees. Real life situations or problems. The International Space Station orbits Earth at an altitude of about 240 miles. In the diagram, the space station is at point E. The radius of the Earth is approximately 3,960 miles. To the nearest 10 miles, what is EH? The distance from the space station to the horizon. So here we have the drawing, and this is the radius of the Earth, and we need to find EH. So I know, or I need to find EC. So ED is equal to 140 that he said it before. So it will be 240 miles. So EC, it will be ED plus CD. So CD is the radius. It will be 3,960 plus ED, which is 240. By using your calculator, it will be 4,200 miles. Now, it will be like a triangle or a right triangle, so I can use the Pythagorean theorem to find the unknown side. So EC squared equal EH squared plus CH squared. Pythagorean theorem, I'm going to substitute the known things, so it will be EC for 4,200 all squared equal EH squared plus 3,960 all squared. Use your calculator and move it to the other side to get EH squared. So it will be 1,958,400. Take a square root for both of them. So it will be EH equal 1,399. To the nearest 10 miles that he told us, or he needs to find it approximated to 10 miles. So the 9, it will push the 9 to be 10, and the 10, it will move to push the 3 to be 4. So it will be 1,400 miles. One more example. Find the length of radius, identify the point of tangency, and write the equation of the tangent line of that point, at that point. So here we have the circle on the coordinate plan, and this is the center. I need to find the radius, so I can count the squares here. So the radius here, it will be 2 units. And I need to find the tangent point, so it will be here. This is the line, and it's tangent at that point. This is the tangency point. So I can move 3 on the x-axis and move 4. So the point of tangency is 3 and 4. Now I need to find the equation of the horizontal line through 3 and 4. So here is the line, it's horizontal or parallel to x-axis at y equals 4. So the equation for this straight line, it will be y equals 4. Another example. The segments in each figure are tangent to the circle at the points shown. So here we have 2 tangents, AC and AB. Find each length. I need to find the length of these 2 tangents. So I need to find x first to substitute to get the length of these 2 tangents. So the tangents from point A are congruent. Both these 2 tangents are equal. Solve these 2 lengths, 2x all power 2 equals 8x, as this length equals that length. So to get x, so 2x squared equal 8x, I'm going to move 8x to the other side by different signs, so it will be 2x squared minus 8x equals 0. I'm going to take 2x common outside. It will be 2x times x minus 4 equals 0. Now I have 2 answers for the x. So I'm going to take 2x equals 0 and x minus 4 equals 0. So here we have 2x equals 0, so x equals 0. And the other side, x minus 4 equals 0. So here it will be x equals 0, and this will be x equals 4. As it's impossible to the answer or the value of x to be 0, so I'm not going to take this answer. I'm going to choose x equals 4 to substitute to get both sides or these lengths or the tangents. So AC equals 8x. 8 times 4, it gives me 32. And AB equal 2x squared equals 2 times 4 power 2, which is equals 32 also. Both of them are equal. Another example, PR straight line, PR line segment is tangent to circle Q at R, and PS line segment is tangent to circle Q at S. Find measure of angle Q. So I need to find the central angle. Okay. I think that we are going to use the circumscribed angle theorem. So here we have that if this is a tangent PR tangent at point R, so this will be 90. And PS, which is a tangent, so this will be a 90 because a tangent and a radius, the relation between them are perpendicular. So measure of angle P and measure of angle Q are supplementary. So here, these 2 angles are supplementary. So I can use it from the circumscribed angle theorem. So measure of angle Q is equal 180 minus 42, and it gives me 138. Another example, PR line segment is tangent to circle Q at R, and PS line segment is tangent to circle Q at S. Find measure of angle P. I need to find measure of angle P, which is x degrees. So I need to find x. So let's use the theorem, the circumscribed angle theorem. As we have these 2 tangents, the relation between the tangent and the radius is 90 here and here. So I can say that both of these two angles are supplementary, right? So measure of angle P and measure of angle Q are supplementary. So by using circumscribed angle theorem. So, to solve x, I'm going to add x plus 3x equals 180. Combine like terms, it will be 4x equal 180. So x, it will be 45. So I can substitute by x here 45. So measure of angle P, it gives me 45 degrees. Thank you. And if you have any question, just contact me. Thank you very much.